course, obviously the list goes on. So what I want you to do is I want you to try to read it by yourself, okay? And not all the questions you can do. Essentially the difference you should notice between part 1 of this topic and part 2 of this topic. In part 1 of linear motion, what happens is they give you a position and they ask you about velocity. And then sometimes they give you velocity and they ask you about velocity, and that's perfectly fine. In part 2, what happens, they take a velocity and they ask you about position. So this is the part that you guys don't know how to do. You don't know how to work backwards. Okay, so if you ever see that they ask you, like they're giving you velocity and they ask you about position, don't do those questions. Okay, and of course you can look at the answer key and you can tell which ones are relevant and which ones are not relevant to you. And then I tell you what, on Thursday before the quiz, I'll even open it for any questions if you guys want to talk about anything a little bit more, especially after I post the solutions. So that'll be the end of lesson number 12 for us. Okay, so that's linear motion. No, this is lesson 11. Okay. So today we are going to take a look at lesson 12. And notice how after lesson 12 we start integral calculus. And the way that this with calculus is built is integral calculus goes basically starting from well, next week. It goes for a good year or more than a year. Okay, so what I mean by that is you kind of pick up a lot of it while you're in Calc AB, and then you come back to 12th grade if you choose to, and you learn more of it. Okay, so 12th grade Calc BC is not harder than like Calc AB. It's basically just filling in anything that you don't have, right? So I think I've shown you this chart before, and then somebody even said is, hey, should we just try to do it all in 1 year? And you know, some of my best students have tried, but they're like, it's too much still because of all the other APs they take. So anything that's in blue is Calc AB. So you'll notice that some parts of Calc BC, the purple parts, they're in Calc AB topics. So this is the end of differentiation, and then that is the start of integration. So integration, even though it looks like it's fewer lessons, they're more in-depth sort of lessons, okay? And then next year, basically it's those 2 units primarily, okay? So the current senior class that I have, they're very strong. So we're probably gonna finish the course maybe even a month earlier than was originally planned. So, you know, once you're finished, it's not so intense. Sometimes you don't have a homework for like 2-3 weeks in that class, right? So it's kind of nice. But when you do have a homework, it's, you know, it's very targeted, it's a very focused sort of homework. All right, so let's go ahead and begin with lesson number 12. I'm going to go ahead and label this as the derivatives of inverse functions. Every year they give one question on the exam about this topic, and this may be the one question people get the wrong the most. Like maybe only about 20% gets it correct. So I will be spending some time showing you why also people get things incorrect. Yes, please.
I was gonna say, so we have Ken in the room that you teach after Calc BC. So we see how you're teaching them polars and stuff like that.
Yeah.
And then Zishan was sitting there, he was like, see that? Don't join Calc BC. You don't want to learn polars.
Listen, I have never been one to force people to do anything ever in life. So, if you choose to not be in it, I would never hold it against you, you know? So, as much as I give that offer every year, most folks still end up in it, you know? So, hopefully, up to you. You can make a judgment call in March, April, May, whenever you're okay. Of course, it's an easier to sit in business math or college math. I think those are the 2 options usually. So we might even have some more math teachers next year.
Oh, we don't.
talking about hiring some new math people. So, you might even meet,
I don't know yet, I'm not saying I'm not going to.
Yeah, I've never been one to try to, I know some AP teachers, they try to bring the crowd their way. I'm not like that, I do my job and I go home. Okay, let me show you guys something before we start, with derivatives of inverses. So this will start to help you understand why this topic tends to be the one topic people get wrong a lot. Give me 1 second, there's like a full screen button here. So you have a function right over here, and the equation of this function is 0.2x squared. Do you guys remember, let's make it even easier. Do you guys remember something in in pre-calc, where we learned to take a function and then find its inverse? Do you guys remember that topic? Yeah. Okay, so do you guys know what the inverse function of y equals x squared would be? What would it be? Okay, so here's a good start. Think about y is equal to x squared. So we'll call that f of x equal to x squared. And then let's think about its inverse function. Its inverse function would be the square root of x. So these two are inverses of one another. So one of the things that you guys have learned about functions and inverse functions is, let's suppose that you were to plug the number 2 into this function. What would you get as an answer? 4. Okay, now let's plug the number 4 into the inverse function. You would get an answer of 2. All right, let's try another one. Let's think of the number 3. What is the function at 3? 9. Okay, now what is the inverse of 9? 3. So one of the things that we learned is, when it comes to a function and its inverses, you don't necessarily need to know everything about the inverse function in order to graph the inverse function. All you need to do is take the coordinates, so take 2, 4, and then I gave you a specific word for this. What is it called when you make it into 4, 2? No, it starts with the letter S. It's not a math word.
Switch.
Swap.
Swap. Okay. So literally, the x's and the y's are swapped. Okay, so what ends up happening is, if your function was going through 2, 4, your inverse function is going through 4, 2, and so on and so forth. All right. So this is the function and this is the inverse function. So that is the pre-calc end of this conversation. And that's pretty much all we really did. Today though, we learned something a lot more confusing. Today we think about the question, how is the derivative of this one related to the derivative of that one? Okay, so what we can do just manually is we'll go ahead and take their derivatives, because these are not that hard to take derivatives of. So what's the derivative of x squared? Okay, so you would say the derivative of the function is 2x. Now let's work on the derivative of the inverse function, but first you should know how it's written. The way we write it, we write down f inverse of x, and then we put a derivative in the top right corner. Because notice that normally where we would have put the little derivative symbol, there's already an inverse there. So this is one way to say it. And the other way to say it, while we're just kind of looking at things, the other way to say it, this is more popular on the AP exam, is they'll put a derivative mark on the f inverse part, and then they'll put the x there. So any way that we process this, what's the derivative of the root of x?
1 over 2 root x.
Alright, so this is going to give you 1 over 2 root x. Alright, now let's give it some thought. Alright, let's take the number 2 and plug it in. What is the derivative at 2?
4.
What is the derivative at 3?
So 6.
It's not 9 anymore, okay? So you have 4 and you have 6. Alright, fine. Let's compare that to the derivatives of the inverse function, okay? So First, let me write it down properly. F inverse derivative at the number 4.
Wait, so you want to start with the second way?
Either way is fine, but the one that's more popular on the AP exam, Jenna, is the one on the bottom, okay? Okay, and then the other one was at 9. I want you to think about those two problems right over there. What would the answer to the first one be? 4. What would the answer to the second one be? So today's lesson is all, so this might already make sense to some people, but to some folks, you can give them all the formulas in the world. It's just, it plays a mind game on you. And that's why 80% of kids get this question wrong. So I will teach you this topic, but I already know that so many people are gonna get crossed up and they're probably gonna get something wrong on it, okay? Do your best, inshallah. So what's the relationship between the derivative of the function and the derivative of the inverse function? What type of relationship is this? It is a reciprocal relationship, okay? So that's essentially what ends up happening. Now let's take a look at what does that look like as a picture. All right. So give me 1 second. Let me just move things back a little bit. This works a lot better on a computer, not on one of these boards, but we'll do the best we can, inshallah. So I've got the function f of x is equal to x squared, and so I will start from, let's suppose, negative 4, and I will go until positive 4. Okay, so alright. So is this what you expected for the graph of f of x is equal to x squared? Yes or no? Alright, cool. Alright, the next thing that we're going to do is, I don't want to mess with these anymore, is I'm just going to drag this little thing around, and we looked at some numbers on the derivative of x squared. What's the first number that I did for the derivative of x? It was at 2. Okay, so I'm going to go ahead and take this cursor and move it all the way to about 2-ish. I'll do my best. So it's about there. It's hard to maneuver with this. What does it tell you that the slope is right over there? Yeah, the slope. So slope is rise over run, right, guys? It's about 4. Yeah, it's just, sorry, I'm trying to move it to exactly 2, but it doesn't want to listen. So.
Oh, there you go. It hurt me.
It hurt me. So there you go. Now what I'm going to do is I'm going to show you the inverse relation. So there was another green dot, I don't know if you noticed, but as I was hovering over this one, there's another green dot on the bottom there. And so I'm going to press this button over here. All right. Now when you look at this, I want you to why is this side here though? That's an issue. No, this thing is choppy, it's not working properly. I think maybe because I changed the function, and that's why. Because 1 divided by 4 is not negative 0.13. Yeah, there's something a little off with this. I wonder if we caught it or not. Chill, okay. We'll do it manually. Okay, so on your notebook, that's fine. On your notebook, I think it's probably my fault. I shouldn't have changed the function there. So, on your notebook, basically you want to go ahead and make a function that looks like this over here, and write down that that function is your f of x function, and that is x squared. Okay. All right. Then pick out 2 points along the way, as we just discussed. One of them is going to be 2, 4. So let's call that right there, your 2 comma 4. And the other one that I used was 3 comma 9. So notice that one of the qualities of this function is it shoots up really quickly. So there you go. I apologize for that app, that was not intentional. So 2 comma 4 and then 3 comma 9. So you want to label those in your notebook. Like that. Okay? And we just found the slopes of those 2 points. Those slopes were respectively 4 and the number 6. Alright? Now what we're gonna do is we're gonna go ahead and make the inverse functions graph. Okay, I want you to visually see what happens on the inverse functions graph. So the inverse function, that's what I was trying to show you over there. The inverse function being the square root. We know that the square root family looks like this over here. And we did not check it at the numbers 2 and 3, we checked it at 4 and 9. So, you know, it's not to that same exact scale, but let's suppose that this right here is your 4. And let's suppose this right over here is your 9. So this is the inverse function, and the inverse function is the root of x. And when we found the answers, they were 2 and they were 3, respectively, like that. Now, let's talk about the slopes that we got at those 2 points, okay? What was the derivative that we got right at 2? It's on the board.
4.
Alright, so the derivative here was 4, meaning the slope of that red line is 4. That's what I was trying to show you there. Okay, what was the derivative at 3?
9. Oh, sorry, 6.
It was 6. Okay, notice how it's just a little bit steeper than the other one. Now let's go to this bottom graph. Okay, let's go to the bottom graph. In the bottom graph, what did we discover is the slope of this line over here at 4. So the derivative, this one is supposed to be 1 over 4. So I'll go ahead and I'll write down f inverse derivative, because this is the inverse function, is equal to 1 over 4. And then right over there, how much was it?
1 over 6.
1 over 6. So f inverse derivative is equal to 1 over 6. Alright? So as a visual, just as a visual technique for you guys to kind of look at what we just did there, you now know everything about the pre-calc. As Mason said, this is basically the swapping of the coordinates. But then you've also come to discover that actually you can tell the slope of the derivative of the inverse. All you need to do is just take the regular slopes that you got and do what with them once again? What is this called? From 4 to 1 over 4? This is called a reciprocal. So it's not just taking it and flipping it around or anything like that. It's an actual reciprocal that you do with the slope. So that's the relationship between their slopes over there. Now, as we get into this lecture, we'll also talk about the formula that is designed for this. I'm going to skip over a few slides. They're a little bit useless now because I've done the stuff that I have on the board right there. We're going to go to this slide over here. I want you to write down 2 formulas in your paper, and I'll explain them to you as well. The first one I want you to write down is, you will rarely find this anywhere, but it's actually the more sensible way of looking at it, and probably how you're going to end up memorizing this formula. So g derivative y is equal to 1 over f derivative x. This is the unofficial formula for the derivative of an inverse. The official formula that the AP exam gives in its curriculum guide, which I personally don't like because you just kind of get lost in the notation and you forget what it's trying to say to you. So let me read it to you. It says, if you are asked for the derivative of the inverse function, again, the derivative of the inverse function, that's the title of the lesson, at some value of x. It says you can find this and the way you find it is you do the reciprocal of, so we know that definitely it was supposed to be a reciprocal, but I think it's that bottom part that drives people nuts. It says you have to take a derivative of the original function, meaning that one over there, and then you need to evaluate it at the swapped coordinate, like this over here.
So you can use either over formula, or they could.
They are the same formula, Mason, but the thing is, the one on the top, I just made that one up because it's functionally more useful. It's not really a formula, and I'll explain that in a minute why I wrote that one up. But the one on the bottom is the official formula for the derivative of an inverse, okay? All right, now, we haven't done a single example yet. That was just something for you guys to think about. So if you're looking at this whole x and y business, why isn't there an x here? Why is there not a y over there? Why are they swapped around like that? The way that happens is, look, when we plugged in 2, we ended up with 4, but that's for the function. So in the inverse function, we had to do it the other way around. We had to plug in 4 to achieve a 2. So basically what it's saying on the top end over there, it says, let's suppose that f and g, they're inverse functions. Okay, let's suppose they're inverses. Well, if they were to ask you a derivative of an inverse, that y is the y value of the original function. All right, if they were to ask you for the derivative of an inverse at some of its values, that value is actually the y value of the original function, like that. They get swapped around. So I wrote it like this, so that you understand you're always supposed to swap the coordinate when you're actually trying to find the answer. Let me go through a few examples, and you'll start to understand where this comes from. All right, so go ahead and write down the first one. I'd highly recommend that you write the whole thing down, okay, like word for word. Again, I'm trying extra hard to get as many people to get this question correct, considering how most folks get this thing wrong, okay? So it says, all right, let's suppose that we had a function called x squared, right? So f of x is equal to x squared, and we give you the piece of information that g is an inverse function. Make sure you write it exactly the way that it is, with the words and all. Alright, so g is an inverse of f, and they'll tell you that, okay? So you might be thinking to yourself, oh, do you want me to sit there and find the equation for the inverse? And the good news is, no, you don't. Okay, you don't have to do that because they're not asking you for the equation of the inverse. They're actually asking you for technically a derivative, which has a different formula altogether. Okay, so it says we'll give you a hint. Even though we didn't need this, we have an equation we can plug in ourselves, but they're giving us a hint. They said f of 3 is equal to 9. And our job today is to find g derivative at 9. Alright, so I want you guys to take a look at this formula. This formula works really well to kind of fit into the way the AP problems are designed. So I kind of designed the formula based upon the questions that were being asked on the AP exam. Alright, so g derivative 9 is equal to the reciprocal of f derivative. Here is the only issue. This is why people get it wrong. That's not going to be a 9. Okay, impossible. That can't be a 9. What number does that need to be?
3.
That needs to be a 3. That's what drives people nuts. Like, how does that work? Again, if f is going through 3, its value is 9. So now when g is going through 9, all right, its value is going to be 3. So we learned that you can get that answer, but you need to take a reciprocal of the derivative at that swapped out coordinate. So look at this. This is a 2, but here on this axis, that's a 2. This is a 3, but on the other axis, that's a 3. Here's a 4, but look at where the 4 is on this axis. Here's a 9, but look at where the 9 is on that axis. So it's not the reciprocal of the number itself, it's the reciprocal at the swapped out coordinate. So what you're supposed to do is find 1 over f derivative at 3, not at 9. Now what I tell students is make sure that you never put the same number back into that right there. And that's a safe bet unless they give you something that's exactly there. Okay, so once you understand that part, it's actually very easy once you set it up. So what is f derivative on 3 going to give you according to this over here?
6.
So there you go, the answer is going to be 1 over 6. And I actually started off with a bit of a picture to help you kind of process that first example. And so there you go, we just found the answer right over there, alright? You end up with 1 over 6 as your final answer. Notice how G goes through 9, okay? It definitely has a coordinate at 9 itself. Yes, question?
So we need to find the derivative of f of x first and then we can do the bottom short.
You take the function, okay, so they ask you for the derivative of an inverse. You don't take a derivative of the inverse. You don't find the inverse function. You go over to the function. Take its derivative. Fine? Do the reciprocal of it. The last hurdle is to make sure that you don't plug in the same number they asked you. Don't plug in the number 9 into that, because that function doesn't go through it. It goes through 3 instead. So that swapping of the coordinates is where I lose most of my crowd. Okay? Alright. Why don't you guys try number 2 by yourself? Okay? Look, I'm gonna be honest with you. At this stage, if it's still just not clicking for you, it doesn't click for most folks. If you just follow along with the formula, you'll be okay. Alright? You'll get the answer eventually. This might help for you guys to think about that. Okay, hopefully you got that part down, right? Alright, what number don't I put in here?
7.
Don't put 7. Okay, make a note of that over there. Because again, it's not something that you will actually get an answer to. It's this one that you need to plug in. Okay, so you plug in 2. Alright, what did you guys get as an answer?
1 over 12.
Alright. So of course they'll have a wrong answer choice there where you had plugged in 7 into the derivative of the function itself. You know, that probably have something like that. Okay, go ahead and try the next 2 by yourself. Read them carefully. They're just a little slightly off from perhaps the previous slide, and I kind of fished around through many years and found every way that they've ever asked this question. It took some time, and kind of sort of brought it in. So, are you guys understanding that this means that they're talking about inverse functions?
Yes.
Okay, so, alright. Make sure you write it down. Do you guys have an answer for first one there?
1 over 10.
1 over 10?
1 over 10.
The fourth one is just a little different. I wrote this lesson a long time ago. They tell you G of 8 is 1. question, where did you guys find the derivative for this
The
one?
one.
At 1. I just want you to know something, okay, look. In all of these questions, 1, 2, and 3, look at where they started you off, okay? They told you that the f of 3 equals 9, the f of 2 equals 7, the f of 5 equals 29. You later on, with your understanding of pre-calculus, you made the conclusion that what that means is g of 9 equals 3, g of 7 equals 2, and g of 29 equals 5. In this problem, look at where they started you up. They actually told you that the g of 8 is equal to 1. They're not plugging in a 1 to give you an 8, okay? And by the way, you could have done that yourself. You could literally see that that's true, right? So they're telling you g of 8 equals 1, well that's all you needed anyway, right? Every single time you just need these two numbers to work in that order for you. See that? 7 and 2, 7 and 2, 9 and 3, 9 and 3. So the fact that they gave you 8 and 1, you just go ahead and do your thing. And what did you guys get as an answer for
1
that?
over 11.
Alright, so the answer to this is 1 over 11. Now Jenna here has foolishly said that she's enjoying this topic, and nobody enjoys this topic. I'll keep showing you.
It's probably gonna get harder. But
Yeah, it's, again, I'm venturing into the table format of this that they've started to now give questions about. Alright, why don't you guys go ahead and do the next 2 questions. Class ends at
9:33, bro.
9:33. Let's try to get through these 2 questions. And I don't think I can award you with homework, though. Don't worry, when we start the next part of calculus, you'll just be rushed with a bunch of homework again, just like the beginning of calculus. So, absolutely don't mention it at all. I'm always here for you guys, you know. Sometimes I sit down, I'm like, I'm not giving them enough homework these days. What's going on?
if you're not doing it, other teachers are. I feel like if you think about it too much, it makes no sense, so I'm just not thinking, I'm just letting my hand do it.
I could have just jumped to this part, but I'm not a big fan of just telling people, just do it my way and be done with it. I really wanted to make a valid attempt at explaining to you where we get the logic from.
Yeah.
And I even brought in the app, that didn't work, but and at the end of the day, yes, I could teach you all the shortcuts to math, and of course you could survive it, but it's always nice to know, like, I've always been curious, like, where do these things come from? I really wanna know, like, even if it's not my topic, I just wanna know where it came from, that's all. Anything at all, I'm curious, so curiosity is what gets me there, but, hey, what did you guys get for this?
Negative 1.
So,
1 over negative 1.
okay, so this is -1.
Mm-hmm.
Okay, real quick, what is this one right here?
1 over 4.
1 over
Yeah, this one's
4, did you say?
4.
Alright, so, I mean, you could probably do most of the homework, there's not much to it, but you, want to start, and I'll probably make it due on Monday, I'll probably assign it on Monday, and we can do it. Alright, that's a wrap for the week, you guys.
Do I also
I already